Hi there, my name is Ian Gibson and I'm an electrical instructor at Okanagan College. And today we're going to talk about the relationship of current, resistance, voltage, and Ohm's law. Now I realize that you're probably watching this and don't have a lot of experience with electricity, but essentially what we're going to talk about is how the basics work and how we can use electricity to our favor. Now, it's essentially what we're looking for is current. Current is what powers all of our devices. And with current, we need electron flow. And this is a charge from negative to positive. Okay? Awesome. Voltage is what drives current. Now, voltage doesn't go anywhere. It's just there. It's actually a potential difference between 2 points, from our negative terminal to our positive terminal. Okay? Current will flow when voltage has two slightly different numbers on either end. Okay? With a little bit of volt drop, we'll see a little bit of current flow. The higher the voltage, the more current we have. Let's talk a little bit about current. This is what we call a series circuit or a direct current circuit. If I have negative, this is where all of my electrons are and they want to go this way. Now let's give ourselves a voltage of 120 volts just because. Now what it's going to do is this is a conductor between 2 points, okay, from source to source. What we're going to see is current flowing in this direction. Okay, it's going to flow there, and then as it goes through the source, it's going to go back and forth again. Now, we haven't really talked about the opposition of all of this, and that's resistance. Okay? Now, resistance is like the squeeze on a conductor. As we pass electrons through a conductor, that conductor has a resistance, and it's going to limit the current flow. You'll see that I've now drawn a circuit on the board. This is a series circuit. This series circuit will experience all three parts of this: current, resistance, and voltage. Current is the electron flow. Resistance is the squeeze on the conductors or at the loads. And voltage, which is where we have our source. This would be like your panel at home or something like that. Now, we haven't talked about yet what terms we use for our current, our voltage, and our resistance. If we are looking for an ohmic value or resistance, we are looking for the symbol for the ohm. Okay? If we're looking for current, I, we're looking for the amp. And finally, E for volt. Now what we do with all three of these things, current, resistance, and voltage, is determined by Ohm's law. Now, Ohm said, after experimentation, that current is equal to or proportional to the voltage and inversely proportional to the resistance. That looks like this. I equals E over R. Now there's two other formulas that we can grab off of this. Okay, we're going to do some quick transposing. I'm not going to do it here. I'm just going to show it to you. Then we also have R equals E, or voltage, over current. And finally, we have voltage equals current times resistance. These are the types of circuits that we're going to be analyzing in the next 3 lessons. This is what we call a series direct current circuit.